Good afternoon. Today I'm going to talk about Artwork's latest changes to the step output that help model the PC board vias. So I'm starting with an 8-layer PC board, and the input is a series of Gerber files. Then we have a drill file that runs from top to bottom. And for the output, we're going to create the normal 3DI output. We want to create our dielectric bodies. And I'm using a window selection. I don't want to do the whole board because it's too big to illustrate here. I've picked a small section of the board here. Let's run this now. And this will take, maybe 30 seconds to run. We'll pause. All right, we finished successfully, and now we're going to look at our output data. So here's our output data in 3D view. You can see the gaps here where the conductors go. When we output step, we're going to do several things. First, we want to fill in those gaps with dielectric so that we don't have any air gaps. We want to create vias that have holes in them, and we want to take the individual via pieces, and we want this via to be all one piece. Our step output processor will do that. Let's export our step now. Go to File, Export. We want step for finite element analysis. I'd like to organize by layer, although you can also organize by net. Let's look at some of these options because they're important. We want to remove any duplicate pin objects which would interfere with conductors. I'm going to expand the dielectric area just slightly. I need to do that because when I generate my negative dielectrics, I don't want any tiny slivers between the conductor and the dielectric. Merge via parts with the same ID. Now this is the function that finds all of the parts that are a via that have a common ID and creates a single tube. Replace circular vias with polygons with 8 sides. That controls the number of sides, and we typically want only a few sides in order that the mesher is not overwhelmed. We want to add via drill holes to conductors and dielectrics, so when the via passes through a conductor, we want a hole in that conductor so there's no collision. And finally, and this is optional depending how you want to model your vias, it says add drill holes to vias with wall thickness. If you don't check this, the via will be a solid cylinder. However, if you check this, the via will be a hollow cylinder, and this will be the wall thickness which simulates the plating. If you wanted a plug inside that hollow via of a different material, then you could check that. I'll just click Export, and we'll save this. Saved it successfully. Now we've got a step file that we can import into a tool like SolidWorks. So I'll start my SolidWorks and open. I'll select a file of type step, and there's the file we just created. Now we'll click Open. So here's our results in SolidWorks. If I rotate this, you can see that there's holes in the vias. Let's look at it layer by layer and see what we can learn. I'm going to start by turning all of the dielectrics off. So there's a good view of our conductor stack up. If I were to click on this face here, you can see that the face, instead of being just this part, goes all the way from the top to the bottom. There are cylinders that go from the start to the end point. If we click, say, on this face, we can see that's part of our pad, and it's on layer M1. We have a nice 3D model. There's no interference. There's nothing bad that would cause a mesher to crash. Now let's look at our dielectrics. So our dielectric has 2 separate components to it. One is the board section, and then the other is a thin dielectric we've created ourselves that fits between the conductors on the conductor layer. And you can see it's flush with all the conductor surfaces. If you take these two together, that gives us a continuous dielectric with no holes. We repeat that on every layer. If you aggregate all of these dielectric layers and board layers, you'll have a solid block wherever there's no metal. If I turn off the metal, you'll also see that there are holes in the dielectric where there should be, so there's no collision between dielectric and vias or metal. Now we have a database that's ready to mesh. Thank you.